We've mastered the scientific pointy action. We're going to try some vocalization skills. We'll start with a simple O. It sounds like this. O. Here we go. 3, 2, 1. O. Now we're going to try an extended O. It goes like this. O. 3, 2, 1. O. Oh dear. Let's try. We'll try an oo this time. It goes like this. Oo. 3, 2, 1. Okay, let's try something quite technical. An intonated oo. It goes like this. Ooh. 3, 2, 1. You're not bad at the flashy stuff, are you? Stage 3 of the scientific training is synchronization. We are going to put those two, I know it's a tricky thing, we're going to put those two bits together. The finger pointy and the intonated extended oo, it goes like this. Here we go, 3, 2, 1. Scientists call that making an observation. If you notice something happening, you go, because we like it when stuff happens. Oh, there's one other scientific skill you need. It's the extended intonated oo with W's, and there's a brace position like this. Hands here, and like that. And down again, up, down, up, down, up, down. And we combine that with the extended intonated oo with W's, and it goes, woo, 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 woo. Beware! You only ever use that in 2 extreme circumstances. One is as I enter the theatre. You have already blown that one. The other one is at the end of the show. Oh, and there's a final one, yeah, I don't like telling people because it puts them off the show, but it is important. So it's a finger point to the ceiling, point the rest of them up there with it, and do the same with this hand, point it that way, bring these like this and go, that's when things go wrong. we need to use that. Where's the little pointer? Yes, so we need 3 things. Let's go back. For a fire. We need a fuel, we need something to burn, and then we need something to help it to burn. This ingredient floats around in the air. It's invisible, it begins with O, it's not octopus. Yes, is the correct answer. We need we need oxygen for things to burn. Hands up if you think oxygen itself will burn. Hands up if you think oxygen can burn. Hands up if you think oxygen does not burn. Hands up if you don't care what oxygen does. If oxygen burns, we could do an experiment to find out. We could set fire to the oxygen in this theatre, and then that would set fire to the oxygen in the rest of Wolverhampton, which would burn the entire world's oxygen supplies. Brilliant, let's try it. 3, 2, 1, burn! Okay, we'll try that again. Now, a good scientist always repeats their experiments. In fact, the best scientists are the Teletubbies. They do everything again. So, preparing to combust the entire room's oxygen supplies. 3, 2, 1, burn! Does oxygen burn? What burnt then? The wood burns. Yeah, the oxygen helps the wood to burn. We say oxygen supports combustion. And without oxygen, nothing will burn. And in the air, there's not much oxygen. If this was filled with air, only that much would be oxygen. If you're a mathematician, that's 21 parts out of 100, or we would say 21%. But this is not oxygen. In here, sorry, this is not air. Air. In air, there's 21% oxygen. But it's not air. This is all oxygen. And if oxygen helps things to burn. So here, this is not really burning very well, but if you put it in pure oxygen, it's on again, off again, on again, off again, on again, off again, on again, off again. What's coming next? Congratulations! Scientists love that. That's called making a prediction. And predictably, every time we do that, it burns better. So we know we can rely on it, and we like things we can rely on. So we need oxygen for things to burn, and oxygen helps stuff to burn. We need other stuff as well. We need a fuel to burn. There are all sorts of fuels. Underpants aren't very good fuels. Some fuels are better. Custard, if you do the right thing to it, can be quite good fuel. I've prepared some custard here, and I put it in a tube. And if you know what you're doing, it is quite possible to build a custard powder flamethrower. That's a separate lesson at another time of day. So what I've done is put a bit of custard powder in here. And if you treat it the right way, you can make custard powder do this. So if we put enough custard powder, that should be in here, we should be able to use it as a fuel, as something that will burn. Here we go. And it works. And steadily. It's a reasonably good fuel. It burns fairly steadily. But there are some fuels which will burn faster. So I'm going to have a look at one now. And here I've got a fuel. Whoops. And it's a gas called hydrogen. And I just need to get the flow rate down. And I'm going to collect some of this hydrogen gas here, this other fuel, in some soapy bubbles. It's a bit like a bubble bath. So this is a bit like a bubble bath after you've had a vindaloo. Now I know what you're thinking as you're looking at this. Doesn't it look just like anti-gravity poo? In fact, we can probably help it on its little poopy journey. And there she goes. First came into space. One thing we can say about our gas is that it's lighter than air. Now, can you get Derek just on the straight mic out? It's going to do that, yeah, because my voice won't last out. It's lighter than air. But is it a good fuel? No? Hands up if you think yes. Hands up if you think no. Hands up if you're too embarrassed to put your hand up in case you get the question wrong. Now, not to worry, because one of the great things about doing science is we could do an experiment to find out. So I'm going to collect some of this now. Just need a little lump there. That's probably about right. And oh, let's get another. Is that enough? No? You don't even know how much enough is, do you? So, now, if this really is a highly flammable gas, you have to be very careful not to go anywhere near it with a naked flame. That does not mean a nudie flame. Ew, look at me. It means an uncovered flame. You are lucky. But not that lucky. So what you don't want to do is take a flame like that and put it in. Now I know what you're thinking. You're thinking to yourself, Dr. Bunhead, that was foolish, dangerous, and downright irresponsible. Now, I don't condone that kind of science, and I'm not going to be doing any more of it. Not at least for another 30 seconds, anyway. Well, one of the great things about doing science is we get to try things out. So, how about I try doing it on my head? I've never tried it with this stuff before, so I don't really know how well it's going to work, and I don't know how much I should even use.